Welcome back, everyone. Here we are with another episode of the Midnight Sessions. Let's get started. Okay, perfect. Let's talk now about the Ambassador program. This is a huge topic. So, this is a new blog launched on September 25th with the Midnight Foundation. Midnight Foundation launches Quest in advance of Ambassador program. So, here in this blog, they have all these details, but once again, I have created a summary for you guys that I have it here in English. So we're gonna read it together, and then as I read it, we're gonna be explaining and adding some extra details and context so we better understand how this program is gonna work. Midnight Foundation launches Quest ahead of Ambassador program. So the program hasn't been launched yet. It's going to be launched at the end of Q1 2026. The Midnight Foundation has launched Community and Builder Quest on Silly. This is a platform. I'm going to show you that platform later and how to join that platform as well. A community engagement platform starting September 24th. So it's been 1 month already that platform has already been open, but you can join now and start accumulating those points by doing those quests. I'm going to explain all that later on. This quest aim to onboard developers into the Midnight network. So you see there's a lot of focus on developers, rewarding meaningful contributions like creating tutorials, submitting pull requests, building dApps, or helping others in forums. All progress is tracked via a public leaderboard. We're gonna take a look at that leaderboard later on, who is first, who's second, and so on, ensuring transparency and recognition for top contributors. Reaching 1,000 points on Silly is required to apply for the upcoming Midnight Elite Ambassador program launching at the end of Q1 2026. So it is important, right? As you perform some task, you're going to accumulate some points depending on the difficulty of each task. And once you get to 1,000 points, you're going to be able to apply for the Ambassador program at the end of Q1 2026. So you have time to learn how this works, to do those tasks and accumulate those points. I totally recommend you guys that are starting on Midnight that follow the Silly platform and accumulate points on all the things that you are doing at the same time, right? You're learning, you're doing, so those things accumulate points. Objectives and benefits of being an ambassador. Earn rewards for contributions as tutorials, discussions, or code submissions. So that's ways how you can accumulate points. Accelerate technical onboarding through a structured learning quest. Gain visibility on a public leaderboard highlighting impact. I'm going to show you the leaderboard later on. Midnight Elite program. What is an elite? Elite means clan or family in the Mandalorian language, Mandoa, representing community and collaboration. Ambassadors, so this is going to be some task for ambassadors, right? Join exclusive meetups with engineers, dev teams, and partners. So you're gonna have a lot of support to keep doing what you love to do, right? Writing code, embarking developers, businesses. Lead workshops and community events. You're gonna have all the support to do those. Receive stipends for travel and speaking engagements. Review Project Catalyst grant proposals. So that's huge, right? On the last, it was 2 sessions ago, I did a post mentioning this partnership between the Midnight Foundation and the Catalyst platform, right? So now projects are going to be able to present Midnight related projects and being funded by Midnight Foundation by using the Catalyst platform. Huge decentralization through the VINs, right? How to participate. Join Midnight Network on Silly. Okay, so how do you join Silly? To make it easy, you can go to my X profile, Twitter profile, And on my bio, I have this link, bit.ly embark to midnight. If you click that link, it's gonna send you to the Silly platform under the Midnight channel, right? And then you're gonna register and you're gonna be able to start accumulating those points. Build to earn, engage daily, join discussions, contribute technically, teach others, and organize local events. So this initiative strengthens Midnight's mission to foster a knowledgeable, passionate community shaping privacy-enhancing blockchain technology. So I totally recommend all you guys to start accumulating those points on things that you're already doing, right? So later on, if you're interested and recommend it, you can apply for being an ambassador. So now I want to show you how this Silly platform looks like, right? After clicking that link that I show you on my Twitter profile, you're gonna be sent to this platform, which is called Silly, right? You're gonna register and then you're gonna see all these tasks under different groups. For example, we have onboarding, Hacktoberfest, community, build segments, and each of those segments, they have some tasks. So let's take a look at some tasks, right? For example, explore Midnight's network, developer resources, and sharing sites. This task has 30 points. If you do this task, you're gonna get these 30 points. What is another task? Your first contract, mint. If you do that contract, you're gonna get 50 points. Depending on the difficulty of each task, you can see that you're gonna be able to accumulate more points. For example, this task, it has 100 points. So share Hacktoberfest success. So remembering that you need 1,000 points to try to become an ambassador, right? So here, just by doing this task, you're gonna get 10% of what you need to be to be a potential ambassador, right? Community, you have some tasks related to community. Some of them, they restart daily. So you can see these tasks, you can repeatedly do it by a daily means, right? You have build. You can see here some tasks that are worth 300 points. You can accumulate 300 points. That's a lot. Complete Midnight Developer Academy. So that's something that we are doing on this session as well. We are going through the Developer Academy program. So that's something that I'm gonna help you guys out. So and this is really recommended. They have put all the knowledge necessary to build Midnight in this amazing academy program. Okay, so this is Silly. You're gonna be able to accumulate points, and as you go, one nice thing about this Silly platform is that you have this leaderboard. Leaderboard is gonna show all the people that are working on this Silly and what are the points that they managed to accrue so far, right? So for example, if you click here all time, you can see here that the platform already has 112 participants. That's a lot. And you can see here that people has already started accumulating points. And in the first place, we have Island Stephanie. Congrats, Stephanie. She has accumulated a lot of points, pretty much 600 points. So yeah, and you can see here, then it comes OX 550, then 200. So yeah, Stephanie, it's doing a lot for the community. Congrats, Stephanie. So well, this is the ambassador program, how it's gonna work, how to become an ambassador, when it's gonna open at the end of Q1 2026. And I totally recommend all of you guys to join and accumulate points by all the things that you are already doing. Okay, perfect. Let's talk now about Hydra heads. So for that, we have two blocks that we're gonna discuss in this session, and we're gonna put it together, right? The first one, it talks about the Hydra heads as a whole, and the other talks about the partners operating Hydra heads. So each of these blocks, they have its own material and details. as you can see here. But what I did is I have put all these blocks together and I made a summary for you guys as always, and we're gonna read it together and analyze and give some extra context as I read it. So let's go. This is the summary that I've prepared, so let's read it together. Scaling infrastructure for Night token distribution with Hydra heads collaborations. To support the expanded Midnight network and its user, the Midnight Foundation is integrating Hydra, a layer 2 scaling protocol for Cardano, into the Night token distribution, particularly during the Glacier drop event. This ensures high transaction throughput, reduced latency, and cost efficiency without compromising security. So, we have named a lot of different products, technologies, and stuff. So for those that are new or haven't heard, I'm gonna provide a quick summary of each one of those concepts. Pretty much 3 concepts, right? The first one, Glacier drop. What is Glacier drop? I'm pretty sure that most of you already have heard and know what that means, but it's the process of the distribution of the Night tokens. So we have just finished the phase 1 where all eligible addresses claim their Night tokens. Now we are entering the phase 2, which is called the scavenger mine phase. And what happens here? There is been a lot of wallets that have claimed Nights. So that claim process is gonna take place in Cardano. But imagine all these addresses claiming under the layer 1. I mean, the congestion that is going to take place in layer 1 would be catastrophic, right? There will be a lot of congestion, and people will have to pay a lot of fees. There's going to be a lot of delays. So how this is going to take place? It's using a layer 2. What layer 2? Hydra. So Hydra is a layer 2. What means being a layer 2 is that a lot of transactions processes takes place off-chain layer 2, and just a proof or a summary of those transactions are passed to the layer 1, right? So in that way, users, they have better throughput, they pay less fees. Okay, perfect. Let's see now what is the Glacier drop, some extra details. Glacier drop is a multi-phase, right? Phase 1, phase 2, and we're gonna have a phase 3, which is lost and found phase. Multi-billion tokens, it's 24 billion Night tokens that are gonna be distributed for the Midnight network. In phase 1, over 34 million addresses across 8 ecosystems: Edda, BTC, Ethereum, Solana, XRP, BNB, the Binance chain, Avax, Avalanche, and BAT were eligible to claim Night tokens. Phase 2 opens distribution to a wider public. You don't need to have been chosen to participate during phase 2. Everybody, it's free to participate. Some details on later session, I'm gonna explain better how this phase 2 is gonna play out, right? But everybody that wishes to participate is gonna be available to participate. I'm gonna be able to participate. The main challenge, handling millions of wallets claims efficiently on Cardano's blockchain. That's why we're gonna use a layer 2, which is called Hydra. Why Hydra? Hydra enables off-chain transactions processing using Hydra heads, secure temporary ledgers where participants can perform thousands of transactions per second before settling results back to the main chain. So that's what I was mentioning before, right? A lot of things off-chain, right? With high throughput, stuff like that, and then settling those results back to the L1. So just a small proof result, it's transmitted to layer 1 that demonstrates all these transactions that previously happened on the layer 2. Reduces congestion and cost, offers fast finality, and scales linearly as more heads are added. So for the Glacier drop, Hydra acts as a high-speed express line, verifying claims within heads, then recording only summarized results on Cardano. optimizing both performance and decentralization. Okay, so we have this collaborative model and impact. Hydra heads enable independent infrastructure operators. We're gonna see who's those operators that are gonna be participating on this process and who they are, to reach consensus off-chain before publishing results on-chain. So this approach, how this works, ensures security and integrity, demonstrates Hydra's real-world scalability, and sets a precedent for DeFi, enterprise, and high-throughput use cases on Cardano. So the Glacier Drop dApp application, it's the biggest one so far, using Hydra to transact millions of transactions and processing billions of potentially dollars in assets. Okay, then I'm providing here a summary of the second block, right? As I was mentioning, the first one focusing on Hydra heads, and the other block, it's more like who are gonna be the operators. So let's take a look. In this first part of this block, they provide an extra summary of what we talked so far, but we're going to read it together just to make sure that we have fixed those concepts. The Night token distribution for the Midnight network utilizes Cardano Hydra Layer 2 protocol to efficiently handle the large volume of transactions during the Glacier Drop event. We have already said that it's thousands of wallets that have claimed, and they're gonna perform transactions to actually get those nights. This collaboration ensures scalability, speed, and security without congesting the Cardano mainnet. Purpose of the Hydra heads in Glacier Drop. Hydra enables off-chain transactions processing through secure environments called heads. Within each head, transactions are processed quickly and efficiently before final results are posted to the Cardano main chain. So a lot of things happens on layer 2 without affecting layer 1, and then there is a way to just pass a small portion, just approve a result of a lot of things that happen on this off-chain layer 2 to L1. So we managed to have a lot of things happening off-chain, but having the security of the L1, which is Cardano. So we have high throughput and low latency, lower operational cost, and decentralized and secure validation process. Strategic ecosystem partners. So who are going to be those partners operating the nodes in the Hydra heads? The Hydra heads for Glacier Drop are jointly operated by several leading blockchain organizations, each contributing unique strengths. So let's see who they are. Alchemy, a top blockchain development platform providing robust infrastructure for developers and ensuring Hydra's stability for building future dApps. Another one, Edda Labs, a blockchain software consultancy offering enterprise-grade engineering, diversifying operators, and proving Hydra's accessibility to independent experts. Another one, BitGo, a qualified institutional custodian, adding strong security assurances, validating Hydra for institutional grade use. Okay, another one, BlockDemon manages over $110 billion, that's a lot, in digital assets, providing secure, scalable node infrastructure and operational reliability. Another one, Input-Output Engineering, the original architect of Hydra, ensuring that deployment aligns with its research and core design principles. And lastly, Sunday Labs, known for open source Hydra contributions and the first Hydra smart contract demo. That's nice, aligning the deployment with high demand use cases. So really nice choice. Layer 2 is going to be really secure and decentralized, providing the security of the L1 plus the utilization of 6 major companies that is going to offer the trust for this layer 2 process, right? Of settling transactions and verifying those transactions. Okay, what else? Collaborative infrastructure model. Each Hydra head is run by these independent operators who validate transactions of chain. So each one of those enterprises are going to be running nodes that are going to be validating each transaction. They need to reach consensus before settlement and then post a final outcome to Cardano, ensuring decentralization and integrity, right? We are talking about thousands of transactions and billions of dollars in assets potentially. So this model offers fast, cost-effective, and reliable token claims for users, demonstrates Hydra's real-world readiness for production-grade applications. So really happy because Hydra now, it reached version 1.0 and Glacier dropped DApp. It's going to demonstrate how a big application handling a lot of transactions and valuing assets can use Hydra heads for production-grade applications, right? And provides institutional validation of Hydra's security. So ultimately, the Glacier drop serves as a real-world benchmark, providing Hydra's capability for scalable, secure, and decentralized blockchain operation, setting a precedent for future DeFi and enterprise applications. So it's really nice to see how Midnight is using different levels, different infrastructure of the Cardano tech stack as consensus, smart contracts, and even layer 2 as Hydra. Okay, perfect. So now let's continue learning how to write a Midnight smart contracts. This is part 2 of understanding the bulletin board smart contract. So I recommend for anyone who haven't watched the first part to go ahead and watch it. It's the previous session where we explain how the bulletin board logic works, the state enum, the ledger variables, constructor, the witnesses. We explain the macro part of the circuits and what this public key circuit means, which is a hash. We mentioned as well that we have pure and impure circuits and the difference between them. So I recommend you guys to go to the previous session, watch the first part, and then come back and continue watching this second part. Okay, so now that we know what means this public key, we are gonna understand what these post and takedown circuits mean and how they work. Perfect. Let's start with the circuit post. We are gonna pass a argument which is called new message of type opaque string. We learned what this opaque string means, right? It's a foreign type from TypeScript string, right? That we are going to be able to use in compact, but not for calculating circuits, but just as a blob value, right? Okay, and the output of that circuit is going to be an object, an empty array. And now we implement the circuit itself. So the body, it's divided pretty much in two. The first part are assertions, where we're gonna determine if certain condition fulfills, so I can continue executing the other instructions. And if that condition doesn't pass, the circuit is gonna fail and the output is gonna be this message. So let's see what is the condition that needs to pass. So we call assert to make sure that condition passes. And what is the condition? We're gonna make sure that the value of state, that is of type state, it's equal to vacant. So how do we pass that value? We call the state type, which is an enum, and we want this vacant. To access that value, we just need to type point and vacant. It looks pretty much like TypeScript. So we use state point vacant. So for posting something to the board, we need to make sure that that board is empty. That's why we are making this assertion. If it fails, we're gonna return this message, attempted to post to an occupied board. And if this condition passes, then I'm gonna be able to execute these instructions. Okay, the next instruction, I'm gonna update a ledger value, which is poster of type bytes32 with the following value. We are gonna call the pure circuit public key, right? I'm gonna pass these values. What are the arguments necessary for public key? So remembering from the last session, we studied the circuit public key. We're gonna pass two arguments. One, it's our secret key of type bytes32 and an instance value of type bytes32. We're gonna calculate the hash using those two values, and then the output of that hash is of type bytes32. Perfect. So let's see here. I'm calling that pure circuit public key, and the circuit key, I'm gonna get it from this witness function, which is a local secret key. So it's the first time that we are actually using a value from our witness. So we can see here that we declare this function, local secret key, which is a witness. We are not passing arguments, and it's of type bytes32. As we mentioned in the previous session, in compact, we define the name of the function, the arguments, and the output. But the actual implementation, it's under this file witness.ts, right? And this implementation doesn't live on chain; it lives off chain. We're gonna study the implementation later on. Okay, so we are calling this function local secret key that is gonna return a bytes32, which is perfect because this argument of secret key, it needs to have this type, bytes32. And next, we are gonna call our instance value, which is a ledger of type counter, but we need it to be of type bytes32. So how do we change the type of a value from counter, to bytes32? So in compact, in Okawa now, we can cast types. How? We use this syntaxes. So instance is of type counter. We first need to cast it to field type using asked field, and then cast it again to bytes32. So in that way, instance now has a type of a value of type bytes32. We are using language version 0.17. The current version is 0.18, right? For the bulletin board, it doesn't change much what we are doing here, but the casting of types, it's more direct now. So we don't need to use this field. We can cast from instance to bytes32 directly. Okay, so what else? Before updating this poster with the hash of our secret key that we call using local secret key and our instance, we need to use this other function, which is disclose. So what means disclose? In compact, anytime that you use a private information to update a ledger variable, you need to make sure to let the compiler know that you are okay with that execution. The way to let the compiler know, it's by using this disclose function. So what I'm saying here is like, compiler, I'm okay using this local secret key, which is a private information, to calculate something and then update this ledger variable. In this case, we are not disclosing anything because we're using public key, which is a hash. Remembering, one of the properties of a hash is to be able to calculate a hash based on some private information, but based on the output, we cannot define the input. Okay, perfect. So we have poster of type bytes32. Now we are gonna update another variable, which is poster pub key. And this poster pub key has type cswap coin public key. So this is a common type in Midnight. And how we're gonna get that value? We're gonna use this other circuit, which is called own public key. Somebody might ask me, Eric, where are you getting that circuit from? I haven't seen in your code the implementation of that circuit, because you have here one public key, take down. Where is this own public key? So again, we have this compact standard library that we are importing, where we have a lot of helper functions, which can be structs or can be circuits. So if we go to the documentation, we can see here that in the compact standard library, we have a lot of structs that have already been defined and some circuits that we can use. One of those circuits is own public key. You can see, if I click on own public key, I can see here the implementation and what its function. Returns the cswap coin public key of the end user creating the transaction, which is what we need, right? We need a cswap coin public key. So I'm gonna just call the circuit, and as an output, I'm gonna get a cswap coin public key. So in that way, since post public key is of type cswap coin public key, I'm just gonna call the pure circuit, and I'm gonna get the cswap coin public key of the user creating this transaction. Perfect. So we now understand what is the difference between poster and poster pub key, right? Of type byte32 cswap coin public key. So poster pub key, it's a common value that you can see from other places. It's something known of a user. Byte32 is a custom value that we are using a hash to represent that value, where we cannot infer anything from that value, which is a hash that connects to the user. Excellent. What else? Then we're gonna update the value of the message. So we are posting something, right? So which means the message now is gonna have some value. Message has type maybe. So now that it has a value, this maybe, I need to put a value on it. How do we do that? So if we are not sure how to do that, we can go back to the standard library, and we can see here that the struct has this type. It's an object with some properties, a sum and value. I can create a value from this type using this constructor maybe, but the compact standard library provides us with some circuits, helper circuits, to actually create a value of type maybe, which are sum and none. If I click on sum, you can see here that I'm passing a value to get a type of type maybe, right? So in that way, we have that value. So perfect. And we have another circuit, which is called none. So we call this circuit none, and we have an output of type maybe, but in this case, it doesn't have any value. So we have these two circuits to create a value of type maybe in an easy way. Excellent. So in this case, that we want to pass a value of type maybe, we're gonna use the circuit called sum. So sum, we pass the type, which is opaque string, and then we pass the value, which is new message of type opaque string. Perfect. But there's something here really interesting. We're using this clause again for an argument of a circuit. That's because arguments and witnesses are considered private information. So we have to use this clause for both to let the compiler know that we are okay, that we are disclosing that information to something, not necessarily disclosing 100% in the sense of the value itself. As you can see here, we are disclosing the value, but in this case, we are disclosing the hash, right? So what is the difference between an argument and a witness? The argument, it's a private information, right? That it's passed as an argument, but that's it. I can use it to update something and nothing more. Witnesses, I can use the value of the output of the function, but also I can update the value of the private information after executing that circuit. So, you have more options. It's kind of a second layer. You can use the value, but then you can update the value if something passes during the circuit. Arguments, you just use that value. So that's one difference between witnesses and passing private information as arguments. Excellent. And finally, we're going to update the value state using the type state that occupied. State that occupied. Perfect. So now we have already implemented the circuit post. Now we are going to implement the takedown. So we know we already have the functionality of posting something on the board, but now we want to take it down. So for that, we're going to implement this circuit called takedown. We are not passing any arguments, and the return of that circuit is going to have a type of opaque string. The return of a circuit can be used by the developer for X reasons, right? You can update something off chain, or you can display something on the UI. It depends on the implementation of the developer. Now we are gonna do some assertions. In the case of takedown, we are doing 3 assertions. Post, if you remember, we were using just 1 assertion. Now we are going to use 3. Okay, what are those assertions? First, let's see if the state is occupied, right? State, we access by putting this point, occupied. Looks like TypeScript. So for taking down something, I want to make sure it's occupied. I cannot take down a post when it's empty. So that's why I'm doing this assertion. If it fails, it's going to return this message: attempted to take down post from an empty board. The second assertion, the poster variable, which is of type bytes32, it has to be the public key, which is the hash, right? The circuit. I'm going to pass my local secret key and the instance. And I'm going to make sure that this hash is equal to the poster. What is something really interesting here is that in Compact, I'm doing a calculation. But after compilation of this smart contract, we're going to get some circuits that demonstrates that I know how to do this calculation without disclosing the private information. So that's where the magic comes from, right? So in this case, I'm demonstrating that I know how to calculate this hash poster using this circuit public key, because I know this local secret key, which is my private information coming from the local witness. Excellent. If it doesn't pass, it means that attempted to take down post, but not the current poster. Then I'm going to make sure that I am the one, the poster pub key is the one creating the transaction. So I'm going to poster pub key and use that circuit that we already started on the last circuit, which is own public key. If it fails, it's going to return attempted to take down post, but not the current poster. Perfect. If those 3 assertions passes, then I'm going to be able to execute these instructions. In Compact, we have a way to use constants as well to store values. So in this case, for my message, I'm gonna store the value of message that value. So message has type maybe. It has this type. To access a value, I need to access this property, which is value. Compact, it looks and it works pretty much like TypeScript. So I'm just gonna call a value of this type, and to access this property, I'm just gonna type point value. That's why here I'm using message dot value. So now for my message, it has the value. Then I'm gonna update my state to vacant, right? Because I have already taken down the post. And I'm going to increment by 1 the instance. So if we remember the previous contract, which was the counter contract, we studied the ADTs of counter, which it has some properties, which is increment. So in this case, I'm incremented by 1 the counter instance. So why am I incremented that value by 1? Well, if you see here, when we are posting, this poster is the hash of a local secret key and an instance. If I don't use this instance that gets updated every time somebody interacts with the contract, what is going to happen is that if a user interacts with the contract twice or 3 times or whatever, we're going to be able to get some patterns out of those interactions because the local secret key is not changing. So the hash is going to be the same all the time. So I'm going to be able to determine if a user is interacting with a contract several times. But if I use this instance that whenever they take down the post, it increments, it means that the hash calculated by public key is going to change all the time. So I'm not going to be able to determine if a user is actually interacting with the contract several times, which is something nice and something that we want for the implementation of this contract. So excellent. We have already incremented the counter, and now the message, since we have already took down the message, we want to represent that as none. There's no value on that message. So how do I get a value of type maybe that it doesn't have any value on it? I'm gonna use the circuit none, right? We mentioned that before. We have maybe, and we have these 2 circuits to get values some and none. So none, it has these syntaxes where the return is going to be a maybe, but it contains nothing. So excellent. So I'm just going to call none of type opaque string, and I'm just going to call it. And this message is going to be none of type maybe. And finally, I'm going to return this former message because when I structure the circuit, I mentioned that the returning value is going to be of type opaque string. Perfect. So now I have implemented my 2 circuits, post and takedown. What we need to do now is to compile it. So to compile, we're going to use this instruction npm run compact. Why? Because on this package.json, I have created this script called compact, which is going to compile the contract using the version 0.25. I'm going to grab my board contract that has extension .compact, which is this one, that one we were looking at right now. And the result of the compilation, I'm going to store it under managed board, which is here, managed board. I have already have some information because I have already compiled it, but we're going to compile it again, and those outputs are going to be updated. Okay, perfect. So let's compile it. If all the syntax is okay, the compilation is going to work. But if your contract compiles, it doesn't mean that the logic was implemented correctly, right? It just means that the syntax is okay and and your contract structure it's well defined. But the logic, we're gonna have other ways to actually test it. But right now, let's compile it. So when I compile it, you can see that it's compiling, and I have 2 circuits. Circuit pause and circuit takedown. Somebody might ask me right now, Eric, I have seen other circuits in your contract. What are those? So if we go back to the contract, we can see here that we have circuits paused, circuit takedown, and circuit public key. What is this public key? Well, what we see during the compilations are impure circuits. Those pure circuits are not displayed on the output of that compilation, right? We're gonna have access to that, right? But it's not displayed as circuits that are exposed to the client during the compilation. So perfect. So if we go back to the compilation, we can see that these 2 circuits, they have this k value, and the rows, which represents the size of the circuits and the number of gates used for the CK representation. So we can see that these two circuits are using the same parameter, K14, and it has one has 10,000 approx rows and the other one 10,000. So they look pretty much similar. So let's see what's the output. So if we go here to manage the board, we can see here that we have the output of the compilation. It's pretty similar in the structure of the output of the counter contract. We have this compiler file, contract file, keys, and CKIRs. Of course, the results is different because it's a different contract. So in the compiler, we have the structure of our contract, the circuits and private information. We have the output of the contract in JavaScript and the types. We have the keys of those two impure circuits, post and takedown circuits. And we have the CKIRs implementations, which are the instructions to later calculate the keys, right? If we see the post instructions, we can see we have here instructions for the calculation of the keys for the post circuit, and the takedown as well. We have some instructions that are going to be later on used by the CK backend to calculate the keys. Excellent. Now let's understand the witness implementation, right? We mentioned that we have here the witness, we have the name of the function, the arguments, and the output. But how do we calculate that output? Where is that implementation coming from? So it's coming from this witness.ts file. So here we have the implementation. So the private information, we can define it the way we want in TypeScript. So in this case, we are defining this type of having this structure. It's an object with secret key of type uint array. Down here, I'm defining a function to calculate a value of that type. So I'm passing secret key of type uint array. That is going to be an object of secret key, the same type of my private information. So the output of my private information is going to be uint array. Why do I want it to be uint array? Well, in my compact, the output of the witness, I want to have the structure bytes 32. What is the representation of bytes 32 in TypeScript? Well, in that case, I'm going to use the output of the compilation contract index DCTS. Where are the types, right? Here, I'm going to know all the different representations of the compact types that is represented in TypeScript. So if I go to witness, I can see here the local secret key, and it's represented in this way. So we can see here that the local secret key is going to have two outputs, one of type T, which is our private information, and the other one, it's the output of this type, bytes 32, which in this case is represented as uint array. So I already know that bytes 32 in TypeScript is represented as uint array. Excellent. So now that I know that, if I go back to my witness implementation, this explains why I'm using this uint array. Then I'm gonna define my witness object. This witness object is important because it's the object used by midnight.js, which is the transaction builder library, and it's the way we're gonna connect our private information with the transaction implementation. So in this case, it's an object. I'm gonna pass all the different functions that I'm using in my construct. In this case, I'm just using one witness function, local secret key. So I'm just gonna define one function, local secret key. And I'm gonna pass arguments using this type constructor. I'm gonna have access to three different states: the private state, the public state, and the contract address. And I can use that to implement the functionality of my witness implementation. In this case, this local secret key is going to have two outputs. One is going to have my type, as we saw before here. The witness, it has my private state type and the uint array. So let's implement that. One, it's going to be my private information that it has bulletin board private state, and the other one is going to have uint array. In my case, I don't want, after execution of the circuit, my private information to change. So in that way, I'm just passing the same private state as an output of the implementation. So I don't want my private information to change. Other implementations, I can assume that I'm going to be updating my private information. So you see, there is kind of two layers. One is the public. You can update it after executing circuits, but in the witness, I can implement changes on the private layer as well. And the last part, it's passing the output of the local secret key that's going to go into the contract, which is of type, remember here, is of type bytes32. In this case, uint array. In this case, we have this private information. What we want is this secret key. So I'm going to pass my private state of this type, and you're going to get the value of the secret key. So perfect. I have already implemented what I want with my private information. Other contracts, depending on the logic and the architecture, this implementation has to be done in that specific way. Excellent. So we now know how to compile and how to read the private information. What we need to do now is actually test the logic. For that, we are actually going to do it on the third part, on the next session, but I'm going to explain what we're going to see. We have this folder called test, where we have the implementation of the testing framework, where we're going to be able to test the logic without using providers, right? So we're going to use a lot this output of the compilation, which is the JavaScript implementation of our contract, plus the types, and we're going to simulate the logic of our contract. But we're going to see that on the next episode. Okay, perfect. Now for the question and answer segment, we're going to take a look at the forum and the community board. I've been taking a look at those two platforms, and in this session, I want to discuss with y'all two issues specifically, right? One, it's this one cannot receive coins from a contract, and this other one, training in TypeScript and compact in Spanish. So let's take a look at those. The first one, cannot receive coins from a contract. Let's open that one. It was created by this community member, Boshako, where he provides some context here. Context and versions. Compact compiler, he's using the version 0.25. The proof server running with this command to initialize it using proof Docker. And he's running the CLI with testnet mode. Some steps to reproduce the failure, right? He tried to send native tokens funds to the contract circuit, deposit funds, when the contract tries to write coin info to the ledger liquidity. So he's using these commands here. So far, during these midnight sessions, we are, as we understand more complex contracts, we are learning different circuits, right? So far, we haven't learned anything about coin management, but either way, we're gonna take a look here at this code just for reference, but I don't expect you guys to understand it right now. Okay, so he's using this circuit called receive to get some coins and introduce them into the contract. He's updating this variable me with the contract address, and then he's updating a ledger variable with this coin info to transform it to coin info, qualified coin info during runtime. Excellent. So we are just getting some coins into our contract. The actual behavior, the proof server returned this error, right? If I otherwise run the proof server found at the following repository, as suggested by the author, the error is not thrown. So this repo, it's from Brick Towers, and they have created a bake proof server that apparently when he runs this circuit, that failure disappears, right? But if the author here, Boshako, uses the proof server from the Midnight documentation, this error appears. So let's understand what's going on. Here, Steven mentioned J. Albert, which is one of the Midnight DevRel team. I see you are on this ticket. Is this respective to the Brick Towers repo? And then Boshako mentioned, no, the issue is the Midnight's proof server when pulling and running Midnight proof server image. The Brick Tower repo seems to be fixing it, and that's why I shared, but as a workaround, I'm in the meantime using, right? So with the Brick Towers proof server, it is working, the circuit that the author wants to implement. So then Sergey, which is one of the authors, collaborators of that repo, of the Brick Towers repo, he mentioned this. The current Midnight Network proof server, latest version 4.00, container attempts to download CK parameters, files from the internet at runtime, which fails. The Brick Towers repository improves this setup by pre-downloading these files and baking them into the image or provided as volume, right? I first reported this issue in mid-May, and since then, members of the community have continued to raise complaints about it periodically. So you can see here that it's about the CK parameters. Apparently, the current version of the proof server, it doesn't download the CK parameters above certain K, right? And in the Brick Towers repo, what they do is they pre-baked this proof server by pre-downloading. They bake this proof server by pre-downloading the CK parameters. So Jay responded back by saying, Boshako, Sergey, thank you for your patience. We have raised this to the team and we are looking into solutions. So right now they are aware of this problem and what K parameter number was needed to compile your circuits. So he's asking, what is the size of your circuits? By default, proof server only handles up to K15. So that's really important. If your circuit is above K15, then using the actual implementation of the proof server, your circuit is gonna fail. Why? Because you only have parameters available within the K15 frame, right? You're not gonna have parameters for circuits that represents K16, 17, and so on. So anything above that, you need to download CK parameters files manually. So this is what the proof server of Brick Towers is doing. It's pre-downloading these files and baking them into the image. So Boshako mentioned here, I see, I've just gave it a try. My circuit is K17, so okay, it's above 15, so probably it's gonna fail, and it fails. I then reduce its logic to the following code, right? He just changed it a little bit. And then what happens here is that the result, the size of the circuit now it's K15, and this was able to run without issues. So he already confirmed that, yeah, the issue is the CK parameters that are not available when running the actual implementation of the proof server. But with the Brick Towers implementation, you're gonna have those other CK parameters necessary to run circuits above K15. So Jay finally responded, Boshako, thanks for the insight. I will share the details with the team and we will discuss the best solution. So perfect. So far, we've been learning how to write smart contracts. We haven't reached that size of circuits yet, right? So we haven't encountered that issue, but for sure in the future, when interacting with coins and other and adding effects to the circuits, for sure we're gonna reach that number above 15, and we're gonna have to use some bake proof server solutions, or by that time maybe the Midnight team they already solved that issue regarding the CK parameters. So perfect. Just wanted to share with Joel in case you are running this issue or compiling circuits above K15. Another issue that I wanted to share with you, with Joel, it's this one here, training in TypeScript and compact in Spanish. This issue was created almost 1 month ago. It's related to a member of the community that they want some documentation and training in Spanish. So there's been some discussion. There's been a lot of likes from the community. And something that I mentioned to Giancarlo is that we have available right now these videos, right? That we are producing pretty much once per week, where you can see here that we have so far almost 20 videos, all of them in English, Spanish, and Portuguese, and it's divided in 3 segments. We have the ecosystem segment, which is more focused on the general public, that introduces Midnight, some concepts related to CK, what's going on within the community. Then we have the segment of contracts. This is more kind of developer focused, where we teach people how to write smart contracts and create dApps using Midnight technology. And the third part, we have questions and answers, where we discuss some doubts regarding the community, some issues, and we collaborate on those as well. So this material could work. You can use it for workshops or training people in Spanish. Okay, perfect. So this is regarding the issues that I wanted to discuss with you. Then we have other issues down here that are related to documentation and blogs. You can see here that people ask, it would be nice to have some information about Midnight. How did all this started? Adapt for broad fungible assets. What is the difference between Solidity and Compact? A demo of using off-chain data. Again, some Solidity versus Compact. So this is nice about the community, right? Because the community can ask for things, and then during discussions we can see what things are being duplicated, what's already been done. We can answer here. So it's a really nice way to avoid duplicate work and create synergy. Some examples of multi-sig contracts, a Hello World application, debugging. So if you are interested in collaborating in one of those issues, it's just entering that issue. You can discuss here. You can provide likes, remembering that if you have enough discussions and everything is okay, this issue is gonna get implemented, right? And depending on the likes, the team is gonna give a specific preference for that issue to be implemented, right? So it's really important, if you want this to pass and be implemented fast, collaborate and provide reactions to that issue. And if you want to implement it, you can actually comment here, okay, I want to do this, and eventually you can be designated as a assignee, right? To do this, to perform this issue. So, well, this is a really nice way to collaborate within the community, and this is open source, and you are free to take a look and collaborate. Thanks everyone for joining another Midnight session. It was great learning together. See you in the next episode. Bye bye.